questions. All right, everybody, welcome to 7:30 class meeting, chapter 25, question and answer session. Before you take the exam, are there any questions that I might be able to help you with? You can type them in the chat, or you can raise your hand and unmute yourself. However you like to do it. Test tomorrow is only on the second semester. So chapters 13 through 19, and then 25. So that's all there is going on for tomorrow. And it is exactly questions off of your other exams. So you've had 4 exams. So I took questions from each exam. Tried to stick to around 12 to, of each exam. And then you get 50 questions that are literally 100% off of the other exams. So you've already seen all of the questions on the final tomorrow. So I put in your last quiz. I put in your classwork. So the only 2 things that need to go in the grade book are the 2 finals, and they will the 2 tests, the test today, the test tomorrow, and they will automatically go in there. So you will see your updated grade as soon as you're done. And then you will see your final grade tomorrow when you take the test. The test will go live at 7 a.m. So you can take it whenever you are ready. Yep. So you can take it whenever you're ready tomorrow. Anything specific we need to know for the test today? So I try to make the quizzes like I make the exams. So the quiz questions are very similar to what the exam questions are. So if I go to the exam on my other computer, so you guys don't see what I'm doing, you can expect questions like you saw on the quiz. Things like, let's see, load. Canvas has been pretty slow today, so we'll see how things go. Must be a bunch of you guys asking. So like, what symbol is used for beta radiation? Like, that's pretty simple. And it shows a bunch of half-lives, and it says, which one do you think is the most stable or most unstable? And then it says, what element does polonium such and such decay when it does alpha? So it's the same as the quiz, basically. It's just different questions that are the same topics. So if you have your work with you, you should be fine. So if you'd like anything in particular, let me know. Just a quick overview while you guys are thinking of questions. If we have alpha decay, we draw the alpha particle, and you can draw the charge or not, it doesn't matter. And then what we do is we just balance everything. 13, there's 4 here, so that means this is 9. 6, there's 2 here, so that means this is 4. Then you go onto your periodic table, and you find that that's beryllium. This is the alpha particle, this is the parent, this is the daughter. In the case of beta decay, we have the beta particle, which is either an electron symbol, or you can do the beta symbol. Doesn't matter. We do the same thing. We do 14 at the top because 14 and 0 is 14. And then we do some number minus 1 is 6. So this is actually 7. Goes up 1. And that's our daughter particle now. This is called the beta particle. This is the daughter. And these are the parents. Remember, what's happening in alpha is that our proton-neutron ratio is unstable. And so this one attempted to stabilize itself by making 2 smaller atoms, by spitting out helium, because helium-4 is one of the most stable nuclei out there. So that was one thing it tried to do. And then, of course, if the resulting daughter is also super stable, then this will definitely undergo alpha decay. In the case of our carbon-14 here, if one of the neutrons becomes a proton, you can see that our number of nucleoids didn't change, but our number of protons did. One of the neutrons can become a proton, and this will spit out a high-speed electron, and that will then cause a more stable daughter nuclei. And then, of course, there is gamma, but gamma is usually just kind of a result of these things. Or you can have something like cobalt-60, which has the reaction where it just kind of spits out energy, but there's none of those on the test. So there you go. So those are the 3 basic types of decay: alpha, beta, gamma. Alpha is the weakest as far as penetrating power. It's still dangerous. It's not like you can just ignore it, but it is dangerous. It causes cancer in your lungs when you breathe it. It also causes thyroid cancer in your thyroid when you eat radioactive iodine. And then there are beta particles. Beta particles are more powerful. They can go through things like paper and clothes. But if you have like a thick clothes on or cardboard, they can be blocked. And they are also damaging because they're high-speed electrons. And then there is gamma radiation, which is the most powerful. It can go up. It can go through up to 6 inches of lead or 6 feet of concrete or dirt. And it is really, really nasty as well. So yeah, we have used radiation in the past to do all kinds of cool stuff. Recently, the vast majority of radiation is used for either cancer treatment or for treating our water to make sure everything's dead in the water. We usually use ultraviolet light for that, but we could also use X-rays and gamma rays depending on how dead you want the stuff in the water. Usually ultraviolet is enough. And then we learned about fission and fusion. Clear canvas, please. So we learned about fission, where you take a otherwise fairly normal isotope and you turn it into an extremely unstable isotope. And this will become a very unhappy atom. And this, instead of doing alpha, beta, and gamma, that is not enough energy release, it then splits into krypton and barium. And it also produces 3 more neutrons. And because it produces those 3 more neutrons, this can then cause a chain reaction. So these 3 neutrons, if we draw them like this, neutron, 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 1, 1, 1, 0, 0, 0. They can all go and hang out with a uranium-235. They can all go and hang out with the uranium-235 and then start this reaction over again. And so that is called nuclear fission, and it will cause a huge amount of energy to be released, and it is used in the first atomic weapons. Then we learned about nuclear fusion. You can do basic nuclear fusion like this, where you get the two hydrogens to fuse together. And what happens is you get, for a very brief moment, you get helium-2, which is very unhappy. And so helium-2 will then turn into hydrogen-2. That hydrogen-2 can hang out with another hydrogen. And for a very split moment, you'll get helium-3. And then that helium-3 can turn into hydrogen-3, or it can stay helium-3, depending on the situation. Sometimes the helium-3 will find another hydrogen, and you'll get helium-4. Sorry, helium-4. But sometimes the hydrogen-3 will find that hydrogen-2, and you'll get the helium-4, but you'll also get a neutron. So in the case of the sun is just happily going through this process and turning its hydrogen into helium, and then turning its helium into other hydrogens, and then eventually turning those hydrogens and heliums into lithium and boron and beryllium and so on and so forth until it reaches iron. Once it reaches iron, the sun is going to, or the star is going to die, and it's going to supernova or nova. And when it does this, it produces every other element on the periodic table. But for us humans, we have figured out that this reaction down here, the tritium and the deuterium fusion reaction, is the one that we want to use because it produces those neutrons. And so in a nuclear weapon, we use a nuclear bomb to set off the fusion reaction. And the fusion reaction produces way more energy than the fission reaction. And so the explosion is so much larger. To give you perspective, the very first nuclear weapon is the Trinity, and it goes off at 20 kilotons. The very first, this is what we call an atomic bomb or a fission bomb. And then we have an H bomb over here. Very first H bomb is Ivy Mike, and it's 10.4 megatons. It scared them, so let's just put it that way. So yeah, scary stuff. Nuclear power plants use nuclear fission, or sorry, yeah, fission, and they just control it using control rods. Control rods are usually made of carbon or some other sort of atom that's able to absorb neutrons. So yeah, that's pretty much everything in a nutshell. Other control rod materials are cadmium. Cadmium is probably used more than any of them. Then there's beryllium. But yeah, so if you're looking at like what is a control rod, you're probably talking about cadmium or beryllium. Carbon is kind of a binding agent. So yeah. That's everything. Only 25 questions, so you guys should get through it really fast. Finals 50 questions. And we will have just like today, we'll have a question and answer session at 11 o'clock. If you like to just wake up and take the test, you can, but and be done with the class. But if you want to wait till 11 and have another session like this, you can. I'll take your questions tomorrow. But it's already been, yep, 1 point per question, just like always. There's already been, what, 6, 7 people who took the test, and there's been 225s, 124, so not that difficult of a test, I guess. And again, this the final exam is literally the exact same questions you've already taken. So like the questions you see today, you will see again tomorrow as the chapter 25 questions that are on the final. They'll be the exact same. But if you don't have any other questions, you're free to go. You can obviously message me throughout the day, and I will come on and help you with whatever questions you might have. Just 2 more days. Easy stuff. And then you guys get 1 year of science ahead. Congratulations.